So, welcome to the discussion of the first assignment in this standard level course. I imagine that for some of the question, you may have had to ponder about questions. You may have struggled a little bit, and it's actually a part of the process. It's completely natural to struggle to try to find a way through problems. In fact, it's the only way to get better at mathematics, so that would be absolutely normal. It's very important you don't take shortcuts. There are no shortcuts in mathematics, no shortcuts to get better doing maths. And what's important is that you take the time to think through problems, think about alternatives. And if you get help, or if you help each other, make sure that you give or receive only hints and not just solutions as whole that you copy down. That would probably not be the best way forward. Okay, having said this, let's see how you've managed. So let's start with recording question 1 here. Let's go. Let's see how you did. Let's start with the big idea in that question that this equation has two distinct real roots. And the thing that follows from that is that the discriminant must be greater than 0. That's my big idea. Step 2 is then looking at the equation in more detail. Okay, this should be a 0 here. And I can identify parameters A, B, and C, which I've done here. Careful with B, make sure it's negative, and don't put an X here. Okay, these are just parameters. And so I'm going to use the idea of the discriminant here. I substitute with brackets, which is really important, especially with negative numbers, in order not to make a mistake. And only then will I have my simplified result, 4 squared minus 4. Then I take this back to the big idea. My discriminant has to be larger than 0. So I have an inequality to solve. Right, so I divide both sides by 4 to get this. Then I will be adding 1 to both sides, and I get k squared is larger than 1. Now normally that wouldn't be a problem. If k squared equals to 1, I take the square root and I obtain k equals plus or minus 1. But with inequalities, this is more tricky. One way of looking at it is to look at the graph. Of the parabola y equals x squared. It's as if here, yeah, if I had, for example, x squared equals to 1, in this case I have k squared, but if it was x squared equals to 1, then I'd be looking for the places where the parabola has a y value of 1. So I can see that I have two solutions. One is here, and the other one is there, at minus 1. With an inequality, it says k squared is larger than 1, so x squared is larger than 1, so I'm really looking at this part up here. And in fact, I'm looking at the parts of the parabola, the branches of the parabola, that start at 1 or minus 1. And you can see k squared is larger than 1. If that is true, then k must be larger than 1, or k must be less than minus 1. Okay. So the set of possible values for k is from negative infinity to negative 1, and from from 1 all the way to positive infinity. Another way of writing this would be to use these funny square brackets like this. I have the set from negative infinity to minus 1. The brackets pointing to the outside suggest that these values are not included, and minus 1 is not included because at that point the determinant would be equal to 0, and then I have 1 not included all the way to infinity, and this is the union sign from set language. It's worth looking at the point distribution in this question. You get 2 points for this big idea here. So we can write 2. And in the mark scheme it will say M2, that means method 2. Okay, very important to show your method. Then you get 1 point here and 2 points for another point to get to this equation, and then 2 points for each, 1 point for each of the solutions down here. Okay, let's look at the second question. So I've written out the expression here, and we've got to first express it in the completed square version here. First step, factorize out 2 so that the x squared term is multiplied by 1. Okay. Next thing we can observe here, it's worth writing that out. The b value is -4, and you know that we've got to take half the b value squared. That is what is going to complete our squared. So I'm going to have -4 divided by 2 squared. That's -2 squared is 4. So I'm going to have to add 4 to this expression and also subtract 4 to undo that. So let's proceed here. What will it look like? Well, completing the square will allow me to rewrite the first part like this. If you expand this, you get x squared minus 4x plus 4, which means I need to subtract 4 here before I add the 5 halves. And if I take these two parts together here, I am obtaining 2 times x minus 2, and this together is -3 halves. And then I can finally simplify it a little bit further by multiplying out again. So I'm obtaining 2 times x minus 2 in brackets squared minus 3. Now take the time to expand this and check that you get back to the original expression here. In the second part of the question, we asked for the minimum value of f of x. Well, from this form, we can easily read off the vertex, which has values p and q. So we can write here, the vertex is going to have the x-coordinate 2 and the y-coordinate -3. Which, if this is minus, this is going to be positive. Which means we can draw the parabola that belongs to this expression here. My vertex is here, and my parabola is opening upwards. Quite a steep one because it's got this factor 2 here in front. Okay. But if you ask the question, if you look at the question again, find the minimum value of f of x, that isn't quite the same as asking what is the vertex. The minimum value of f of x is, in this case, -3. Okay, what it means, the parabola never goes down lower than -3. Is this minimum value here that we're looking for? We could add, and it occurs at the x value, x equals 2. That properly answers the question for the minimum value. So let's look at question 3. First of all, about this maybe unfamiliar mapping notation here with the f double point x maps onto this. This is just another way more familiar to you of writing it will be like this. F of x equals to x minus p, x minus q. We will discuss this notation later on in the course. We call this the factorized form of a quadratic function. And in this factorized form, we can tell the x-intercepts, the zeros, we can tell that they're at p and q. Because if p is 0, then this bracket becomes, if x is 0, if x is p, then p minus p, this becomes 0. And if x is q, then q minus q, this becomes 0. Hence we have the x-intercepts here. So, from the graph that we're given, we can read off that p is minus a half and q is equal to 2. In other words, that would mean that an equation for my parabola is x plus a half, times x minus 2. Becomes plus a half because minus a half. So if you have a plus here, you know that there's an x-intercept at the negative of this value. And if we have a minus 2 here, we know there's an x-intercept at positive 2. Because that's what's going to make either of the two brackets 0. So we've answered question A, now to B. Let's look at two different methods. I'll write method 1. We need to find the minimum value. We need to find where the vertex is. So method 1 is rather graphical. We know that the parabola is symmetric. Okay, so if I have a parabola curve like this, I know that it's got an axis of symmetry. And if my x-axis is like this, and if I have an intercept here and here, then my minimum value here is exactly in between the two x-intercepts. Exactly in between means I can find it by just doing the average, the mean of the two. Okay, let's write this down. X-intercept, not x-intercept, x-coordinate, the x-coordinate of the vertex is the mean of the two x-intercepts. Okay. Do write this kind of sentence down. It's part of your method. Right? And so I'm showing the working now for this. Take the first x-intercept at negative a half, add it to the other one, divide that by 2. This is how you find the average, the mean of the two. And you get 1.5 divided by 2, which is 0.75. Okay. Going to briefly discuss what else you could have done. Let's write this method 2. You could do it more algebraically. We could take the equation x plus a half times x minus 2, or the expression rather, okay, and we could write it in completed square form, then read off the vertex and get back to this. You'll see it's actually a lot more work, but what we can do is we can expand this, in which case we get x squared minus x squared minus 3 halves, minus 3 halves x minus 1. And we complete the square on that. I'm going to do that very quickly, just giving you the answer. X minus 3/4 in brackets squared plus 5/4. What you should do is take the time to verify that this is correct. From this, we conclude that the vertex has the coordinates 3/4, comma. Hang on a minute, this wasn't quite correct. It's not 5/4, but negative 25/16. I forgot to square. And so this is this. But we're only asked for the x value of the minimum value, and that's 3/4, which is the same as 0.75. And by the way, do look back to the graph for this question. Does my answer correspond to, does the vertex looks like it's at this place? And if you check on your paper, you will find that it does. On to question 4. Straightforward trigonometry here. We have a triangle. I've written out the information on it already, and we're looking for this angle here. So I'm going to be using the cosine rule. Always start off with writing it out, so we can also look at it and see what we've got, what we're missing, if this is the right thing for us, like that. We're actually looking for this part here, or in fact we're looking directly for the angle A. So what you wanted to be doing is rearrange this for cosine A, cosine of the angle A, and you're going to get A squared minus B squared minus C squared over negative 2AB if you rearrange. I'm going to rewrite this as this. Pause the video for a moment here. Make sure you obtain this if you solve the formula for cosine of the angle A, and make sure you understand why and how I rewrote it like this. Pause it. Now we can substitute into the formula. B is 56 kilometers. Notice that I'm using units and I'm substituting with brackets. 32 kilometers squared minus, sorry, I was looking in the wrong place there. B is 32 kilometers, C is 48 kilometers, and A is 56 kilometers, and I have to divide by 2 times A, which is 56 kilometers, times B, which is 32 kilometers. Advantage of using the units, I can see that they all disappear. Kilometer squared, kilometer squared, kilometer squared divided by kilometer squared. That's getting something without unit, which I should have since I'm calculating an angle, the cosine of an angle. And so now, for the angle A, I'm going to do the inverse cos on both sides. I'm going to record it like this on the side. And so it's the inverse cos of all of that big expression here. I'm going to cut that short by saying it's the same as up there. Alright, and now I'm taking my calculator. This is the exact answer, and I'm getting an approximate answer, 86 degrees. Normally, I would round to 3 significant figures, but always check in the question. It says here, to the nearest degree. You'd lose a point unnecessarily if you didn't check back. Always go and check back what the question actually required from you. Question 5. Okay. First part of the question, right angle trigonometry. In this pyramid, look for a right angle triangle, and here is a right angle triangle, amongst others, between PQB. We know this length, so we're going to draw out that triangle and work with that. Opposite to this angle is this one. This is the longest side, the hypotenuse, this is the adjacent. We're interested in the height of the pole PQ, so we're going to use opposite and adjacent. Do draw out this triangle in your working. It's really important, even if you can see it straight away in the sketch. It helps to produce errors. So, opposite over adjacent means we're going to be using tan. Let's write out the formula and substitute in it. We know the angle, tan 36 degrees. The opposite is PQ. Note how I substitute PQ here for the opposite. And the hypotenuse is 40 meters, not the hypotenuse, rubbish. What am I saying? Tan is, of course, not opposite of hypotenuse, but opposite over adjacent. So I'm doing that again, tan 36 degrees. The opposite is PQ, and the adjacent is 40 meters. And so, rearranging obtains me PQ is tan 36 degrees times 40 meters. That's the exact answer, and the approximate answer. You grab your calculator and you get 29.1 meters to 3 significant figures. Do write down to what accuracy you're giving your answer. And on to question 7. In questions like this, communication is really crucial. You want to be telling a story. Tell a good story by giving all the elements and start with the most important bits first. So in this case, if I'm looking for the area of the shaded part, I'm going to say that the area that is shaded is the area of the large triangle OAT minus the area of the sector here. And since OAT is a right angle triangle, I can calculate the area of OAT using base times height divided by 2. That's the first part. So, substituting into base times height divided by 2, I get TA times TO divided by 2. Now, I don't know TA. Radius and tangent are always perpendicular to each other, so there's a right angle here. So I can calculate TA using Pythagoras. Longest side squared minus the radius squared. Write it out, calculate, verify that you get 108 centimeters squared for the square of TA. Take the square root, and now take a moment to see if you can simplify the square root of 108. You should be getting 6 root 3. If you haven't done this yet, pause the video now and make sure you understand why this becomes 6 root 3. Now I can substitute in here. I've just calculated TA. That's 6 root 3 centimeters multiplied by TO, which is 6 centimeters, divided by 2, and now you simplify that and you should be getting 6 by centimeter squared, since this is an area. On to the second part of the story. Now, the area of the sector. Formula. We're looking for theta. I'm going to cut this short a little bit, but theta is 60 degrees. You can either calculate that using the cosine rule or using a geometrical argument up here. So you substitute in here 60 degrees in radians is pi over 3, and therefore you obtain 6 pi centimeter squared if you simplify this. Oh, I've made an error. I've confused my two answers above. Sorry about this. This can't be. That was the answer from the question before. Of course, you get 18 root 3 centimeters squared here. Sorry, I was looking in the other side of the question. Okay, and now we can complete the story. We've got both parts. So I can calculate the area of the shaded region. First part, 18 root 3 minus 6 pi centimeters squared. That's the triangle minus the sector. And then, if I want to, I can take my calculator and obtain an approximate version. In question 8, again, tell a story. So here we're looking at the area of the quarter circle here, the big quarter circle. Take away the area of the semicircle. Sorry, taking away the area of this triangle. I've written it up here. And so I can start with some formula work. Pi r squared over 4 is the area of a quarter circle, minus base times height divided by 2. I'm going to be looking to substitute the right values in here. The radius is 2, and the base of the triangle is 2. The height is also 2. It's a right angle triangle. And so I get this. And this simplifies to pi minus 2. Pause a moment to check that for yourself. And in question B, I need to find the shaded area. The story for this is calculate the area of the semicircle, subtract the area of the segment. And so we can substitute into there. In order to calculate the area of the semicircle, I need the radius BP, which is half of BC, which I can calculate using Pythagoras. So now I can substitute back to my story. Pi times square root of 2 squared divided by 2, because this simplifies to half of square root of 8, which is the same as half of 2 root 2, which simplifies to root 2. Okay, so I've got that here, minus the area of the segment I calculated in part A, in brackets pi minus 2. Don't forget the brackets here. And then you will see that all of this simplifies to 2. And we'll discuss question 9 really briefly. In part A, you will be using the cosine rule. Fairly straightforward. To calculate the distance BC is approximately 8.24 meters to 3 significant figures. In part B, it says that this angle is supposed to be 85 degrees. Now clearly it's not 85 in this position. There's another position where the fence could be here, and so this is almost 85 degrees, This is almost 85 degrees here. Sorry, that was the call for lunch for the group. So this is 85 degrees. Okay, we have an alternative position for the fence. And in this case here, we can then use the sine rule. That's question B. Use the sine rule to get AC equals approximately to 18.5 meters. Also to 3 significant figures. And the area will then be calculated without too much problem to 76.4 meters squared. Also to 3 significant figures. Now in the next question, you're looking for the fence being actually in this position. If the angle here is 66 degrees, then this angle is going to be calculated as 180 degrees minus 66 degrees, because this triangle here is isosceles. So this is also 66 degrees. And you get 114 degrees here. And so you can then calculate this part to be approximately 11.2 meters. 3 significant figures. And here, for the minimum length, what you're looking for is clearly that this line from point B to the river is as short as possible. That would be a line that is perpendicular to the river. Okay, so this time you're looking at a right angle triangle. A right angle triangle, and then you can calculate pretty easily CB, 8.24 meters to 3 significant figures.